Okay, this is a question from the homework of chapter 7. I just want to emphasize on the use of the calculator. Although the book emphasizes on different ways of solving those problems, either by hand, using the calculator, using the tables, or a static range, but I strongly suggest that you consider using technology or a static range. That's why it's very important when I provide videos that you see them if you would like to learn how to use technology. This is one of the questions in your homework of chapter 7. Number of chocolate chips in an 18-ounce bag of chocolate chip cookies is approximately normally distributed with a mean of 1252 and standard deviation of 129 chips. What's the probability that a randomly selected bag contains between 1100 and 1400? So he wants the probability of X between 1100 and 1400, and to find the probability of X between 1100 and 1400, you can use a built-in feature on the calculator. It's called normal CDF, normal cumulative density function. You press the second key, variables, and go to normal CDF. The normal CDF requires 4 arguments, 4 values: lower bound, upper bound, the mean, and the standard deviation. The lower bound is where the interval starts at. It starts at 1100, so that would be the lower bound. 1400, 1252, and 129. 1252 is the mean, and 129 is the standard deviation. Let me show you how to use the calculator for this particular question. So you just go to second, variables, number 2, enter. Lower bound is 1100, upper bound is 1400, mean is 1252, if I'm not mistaken, yeah, and the standard deviation is 129. Now, if you have an older calculator that displays on the screen normal CDF parentheses, enter 1100 and put a comma, enter 1400 and put a comma, enter 1252, put a comma, and 129 and close the parentheses. And you're gonna see it right now. There you go, normal CDF. And this is actually how I like you to answer the questions in the forum. So it's a 0.7550, and that should be the answer right here. Okay, let's go to the next question. What's the probability a randomly selected bag contains fewer than 1125? So let's see how do we deal with. So he wants a probability of X less than 1125. Okay, when you do probability of X less than 1125, you use the normal CDF. So you need the lower bound. Less than 1125 can go way below 1125. That's the lower bound. So usually when you have the less than, make your lower bound negative a million or trillion. Just put 1 with so many zeros. Your calculator puts -1 with E99, which means -1 with 99 zeros. The upper bound is the largest number, the interval. You know you cannot exceed 1125, so that will be the upper bound. Then the mean and the standard deviation, and the answer is, so I got 0.1624. Try it out on your calculator. Now, what proportion of bags contain more than 1175? It means if a bag is selected at random, what's the probability that it contains more than 1175? So it's a probability of X greater than 1175 equals normal CDF. You use the feature on the calculator, the function, and then you start at 1175. That's your lower bound. Greater than 1175, it could be go to infinity above 1175. So we'll put a million there, and then we put 1252, and then you put the standard deviation 129. Okay, so and then you use your you go second variable and then normal CDF, and you get the answer. What is the percentile? So D now, what's the percentile rank of a bag that contains 1,475 chocolate chips? Percentile rank, you know, if you, let's say, if I tell you you are in the 90th percentile on the second test, that means 90% of the students scored below you. So the area to the left of your score is 90%. So here, when he wants the percentile rank of that contains 1475, you just do probability of X less than 1475. Always less for percentile. And let me put the less sign here. And that will be equal normal CDF. For less than, you begin with -1 million, always. Then comma 1475, comma the mean 1252, comma standard deviation, which is 129. So this is very much a review of section 7.1, and now I'm going to do another exercise pertaining to not finding probability. If you are given the probability, how to find Z or X. So that's going to be the second question from chapter 7. Okay, the second question: the number of chocolate chips in a bag of chocolate chip cookies approximately normally distributed with a mean of 1162 and a standard deviation 117. Determine the 25th percentile for the number of chocolate chips in a bag. Here is what he means by that. So here's the normal curve, guys, and he says determine the 25th percentile. 25th percentile, he wants the value at the 25th percentile, which is the first quartile. Meaning, what is the X value for which 25% of the values are below it, to the left of it? In order to do that, you can just simply use a function on the calculator called inverse norm. So you go to second and variables, and you choose inverse norm, and I'll do it on the calculator. And the inverse norm requires 3 values inside the function. The first value is the area to the left of my target, and my target is X, and the area to the left of it is 0.25. The second value is the mean, you already have it, 1162. And the third value is the standard deviation, which is 117. And let me show you how to do this on the calculator. So we turn the calculator on. We go to second variables, second and variables, second and variables, and we choose number 3. Inverse norm. Area is 0.25. Oops, I put 25. I will not like that. It has to be less than 1. And the mean is 1162. And the standard deviation is 117. And paste. And it's 1083 cookies. And that would be the answer for X. Okay. Determine the number of chocolate chips in the bag that make up the middle 90-80%. You might came across question middle 70, middle 80, so you're gonna see how this one is done right now. So I'm gonna show you in a second. So here's how you do the middle 90-80%. I'm just gonna show you a visual of this. So 90-80%, this is the area in the middle. Okay. He wants this value and he wants that value, the 2 X values. The one to the left at the beginning of the area, and the other one, this is at the end of the shaded area. This is what we mean the middle. So when we talk about the middle, there are always 2 values. Now, in order to first find the first value, I need the area to its left. And what would be the area to its left right here? Here's what you do, guys. Take 100% and subtract the 98%, which is 2%. Divide the 2% by 2. And if you ask me why we're dividing by 2, because there are two tails, this tail and that tail. And we split up the 2% between both of them, so that's 1%. So the area to the left of the first x is 1%. So you do inverse norm, 0.01, and then you do the mean, and then you do the standard deviation, and you get the answer for this x. How do you find the other x? I'm going to make it very simple. Look what you do, guys. If the first inverse norm you use the 0.01, the second one you have to use 100% minus 1% will be 99%. So always the 0.01 and whatever area you use in the second one must add up to 1. So it will be inverse norm 0.99, comma 1162, comma 117, and close parentheses. And this is how you get the middle 98% of bags. Let's say the question was middle 70%. Look what you do. 100% minus 70% will give you 30%. Divide 30% by 2, you get 15%. So then the first inverse norm is 15%, the area. The second one will be 85%. And how do I know? Because 15% plus 85% will add up to 100%. Okay, part C. Okay, he wants the interquartile range. Well, we know the IQR is Q3 minus Q1. So I need to find the value in Q3 and the value on Q1. This is an X value, guys. And Q3 is the 75th percentile. So you run an inverse norm on 0.75 because Q3 is the third quartile, 75%, 1162, and then 117. You find this value. For Q1, you do inverse norm. Q1, guys, you know it's the first quartile, so you just do 0.25, 1162, 117. Whatever answer you get for Q3 and whatever answer you get Q1, you subtract the two answers to get the interquartile range. Okay, so this is section 8.1 now. A simple random sample of size n equals 49 is obtained from a population that is skewed right. So that population is not bell-shaped, with the mean is 88 and sigma is 7. The sample size is 49. When the sample size, guys, is when you draw sample size of size more than 30, then the distribution of the sample means will be approximately bell-shaped. So even if your original population looks like this, skewed to the right, this is for x, the population of x bar is going to be like this. That's x bar. The mean of the original population will be the same as the mean. So the mean here is 88, and the mean of our x bar will be, that's x bar, will be the same as 88. This is the central limit theorem. Here the standard deviation is 7. The new standard deviation, guys, for the sample means will be the original standard deviation divided by square root of n, which is 7 over square root of 49. And it turns out to be 7 over 7, which is 1. So when you work with x bar, always you get a smaller standard deviation. So the description, it's approximately bell-shaped or normal. Normal means bell-shaped. Find the probability of x bar greater than 89.95. So what's the probability that the sample mean, when he asks you about the sample mean, here's how you do it. So you go to normal CDF, you do the lower bound, which is 89.95, you do the upper bound, which is the sky is the limit when you do greater than, comma, then mean, which is what, 88, And now watch, guys, the standard deviation, it's not 7. You have to use 1. 7 over square root of 49. And then you find the answer. C. What is the probability that the sample mean, when I say sample mean, it's x bar. So anytime you have a sample, guys, you have to use sigma over square root of n right here, not sigma. X bar is less than 85.6. So you have normal CDF, negative a million, then 85.6, comma, let me close this here, the mean, which is 88, and the standard deviation, which is 1. You use 7, you will get the wrong answer. D. What is the probability that the sample mean is between two values? 86 and 90.1. And again, this is normal CDF, 86 lower bound, 90.1 upper bound, mean is 88, and standard deviation is 1, and then you can compute the answer using your calculator. So the bottom line, guys, when the question is about one individual value about x, you just use the population mean, whatever it is. But when the question is about x bar, the sample mean, you must use sigma over square root of n, which is called the standard deviation of the sample mean, or they call it the standard error of the mean, which is sigma over square root of n. The mean itself doesn't change. The original population mean is 88, and the mean here for this is also 88, but much smaller standard deviation.